Hi everybody. We didn't get to finish the last couple of slides on box plots, so I wanted to kind of take a chance here and talk about it. The first couple of slides show the min, the maximum, the median, quartile 1 and quartile 3. That's the 5-number summary. You can look through those slides, but I'm just going to kind of jump into the problem that was there because I think that'll kind of show you what you need to know for box plots. So first is you would need to find the median. Okay, so I gave you a processing class. Just scratch out low, high, low, high, low, high, and then you keep going, right? So that's what we're gonna do. And then you end up with these two middle numbers. So the median will be the average of these two, which will be 24.5. So that's our median. Okay, and I'll write it right here because it seems like you can't see it. 24.5. And then now we're going to do our box plot. So our box plot is going to be the median of the first half of the data. So we're going to do the same thing for the first half of the data. So everything to the left of the median. So scratch out low, high, low, high, low, high, low, high, and you're going to end up with the two numbers again. So the average of these two would be our quartile 1, which is 20. Okay, so we'll do it one more time for the second half of the data. Scratch out low, high, low, high, low, high, low, high, and then you get these two numbers, which you'll find the average between those, and that'll be your quartile 3. So this will be 30. Okay, and of course we know our max 72 and our minimum equals 3. So the 5 numbers together, the min, the Q1, the median, and the Q3 and the max. These are our 5-number summaries. In fact, I'm just going to kind of put them off to the side here so that we have it nicely organized. Median is 24.5, Q3 is 30. Okay, so now what we're going to do next is use these. I'm going to show you two types of box plots. So one is kind of fairly straightforward, simple box plot. I'm going to draw an axis, just an x-axis, and this data was number of months of employment on your slide. And so I'm going to look at my 5-number summary. My numbers go from 3 to 72. So a good number to go by would probably be 10s, starting at 0. So 0, 10, 20, 30, 40, 50, 60, 70. Okay, and just like any other graph, you want to make these equally spaced to get some kind of accuracy when you're sketching. So now what you're going to do is you're going to look at your 5-number summary, your min, your Q1, your median, and your Q3. And we're going to do vertical lines around there. So for 3, I'm going to put a vertical line about here. Q1 is 20, so kind of parallel to my first line. I'm going to do a vertical line right here at 20. I'm going to do a vertical line at 24.5. And I'm going to do a vertical line at 30. Okay. And then I'm going to do a vertical line at 72. I'm going to draw a box around my Q1, the median, and Q3, and then I'm going to extend what we call whisker to both sides, to the min and to the max. So this is one form of the box plot. So now what we want to do is a modified box plot. So we're going to need an extra formula for the modified box plot. So this is called, we're going to find the lower fence which we'll call LF. To find the lower fence, you just get Q1 minus 1.5 times the IQR. And actually, the IQR is called the interquartile range. This is just Q3 minus Q1. In other words, it's the distance between, if this is the min, that's Q1, that's the median, that's Q3, and that's the max. The interquartile range is the distance of the box. Okay, so that's Q3 minus Q1. So the IQR first, then the lower fence, then we call the upper fence, which is equal to Q3 plus 1.5 times the IQR. Okay. So we'll use these formulas, and I'll kind of use them where we have them here. And okay, so basically I'll just calculate the IQR. Q3 is 30 minus 20. This is 30 minus 20, that's 10. So that's the IQR. The lower fence would be Q1, which Q1 is 20 minus 1.5 times 10, the IQR. That'll be 15, so that's 20 minus 15 is 5. The upper fence, Q3 is 30 plus 1.5 times 10. 1.5 times 10 is 45. Okay, so you might be asking, what does this lower fence and upper fence do? Any numbers outside the fence will be considered outliers. Okay, so before we just kind of saw big numbers, and we might have suspected in this data set that 72 is an outlier. However, it would just be that we would just be suspecting. So now we have a solid way of determining whether a number is an outlier or not. So you have the lower fence and the upper fence. Anything outside of the lower fence and upper fence will now be defined as outliers. So 72 would be an outlier. There's an outlier. And then what about on the bottom end? 3 would be an outlier. Okay, but not necessarily 6. Okay, so here, well, we're going to go ahead and draw the modified box plot. Okay, so you're actually going to start the same way. So in fact, I'm pretty much going to use the exact same axis: 0, 10, 20, 30, 40, 50, 60, 70. Okay, and then that's number of months before employment, or of employment. Okay, so we actually are going to do the middle 3 exactly the same. So we're going to do our Q1. That's going to be 20. We're going to do a vertical line. They're at 20. The median's at 24.5, somewhere around here. The Q3's at 30. Okay, so we have our box. Now, what we want to draw is our fences, but this time we're going to do kind of this dashed line indicating our fence at 45 and then also at 5. I missed the mark there. Okay, so this is our fence. Now, what we want to do is, if we see a number outside the fence, like 72, we're going to go ahead and just make a point. And then this would be considered an outlier at 72, that point. And we see an outlier before the lower fence at 3, so I'm going to put a point there at 3. And that's an outlier at 3. So for inside, we're going to make a whisker, but this time the whisker is not going to go to the minimum. It's going to go to the next number that's not an outlier, which in this case is 6. So 6 would be right above the line here. Okay, so we draw a vertical line at 6, and we connect it to the box. And then now we look at the next point that's not an outlier on the other side, which is 42. which would be about right here. I'm going to draw a vertical line here, kind of parallel to the other vertical lines, and extend the whisker. And this would be the modified box plot. So again, the nice thing about this, you can see outliers. You're also able to see different quarters of or quartiles of the data. So I can see that 25% of the data is less than 20. I could also see 50% of the data is less than 24.5. I could also see between 20 and 30. I have contained 50% of my data. So again, you break this up into quartiles, okay, or even into 50%. Here you have the middle 50, which is pretty important. Okay, so now we have a solid way to construct both types of box plots, and we're likely just going to kind of stick with these because they show the outliers. Now let me say one more thing that might help. My eraser here. You can try this on. Well, one, when I sorted the data, I did the sort A, just because it's a lot easier than having to sort 20 numbers. That can even get kind of cumbersome, although it's not impossible. But other thing your calculator could do, if you enter this data into your calculator, you could also push second y equals. This is for box plot. Okay, second y equals plot 1. Make sure it's on, and then go to. There's two of them. Okay, there's this one, and then there's this one. If you want the modified box plot, there should be a picture that looks kind of pretty much like our picture. It has some outliers on it. The other one doesn't have outliers. Okay, so you want to pick this one. But now if you push graph, chances are you might not see it. So do zoom 9, which is stat. If you push 9, you'll get stat. Okay, and that'll automatically zoom around there. So that in itself is not helpful because you won't see numbers. So you need to push trace, and then if you push trace, you'll be able to scroll left and right, and you'll be able to see outlier, the next minimum number, your Q1, your median, your Q3, your next maximum number before the outlier, and then your final outlier. Okay, what it won't show the fence. Okay, so that you'll need to include in your graphs, but it's a good way to check, okay, and a good way to get a quick box plot, which they're also called box and whiskers. Okay, so hopefully that was helpful. Make sure you get the homework done, and I'll see you in class.